Hi guys, I would like to show you how to make an example decay chain using thorium-234. Before we get started, let's review our decay types. So the ones that actually change particles are alpha and beta. So with alpha decay, you are going to we're going to shoot out 2 protons and 2 neutrons. For beta plus decay, oh my gosh, not decay, beta plus decay, we're turning a proton into a neutron, and a neutrino and a positron are emitted. And then for beta minus decay, we are turning a neutron into a proton, and antineutrinos and electrons are emitted. I forgot to include gamma decay, but gamma decay, there's no change in your particles because only energy is emitted, so that's why I didn't really include it. Let's get started with our thorium-234. 234 is our protons plus neutrons. That's our atomic mass. And this 90 is just our protons. That is the atomic number. That's how I knew it was thorium. Let's take thorium and undergo alpha decay. I'm going to point my arrow down, just traditionally, that's what you do. And I'm going to say alpha, so that I know that this is an alpha decay. When I do alpha decay, I'm going to lose 4 from my mass because I lost 2 protons and 2 neutrons. So this is going to become 230. And then since I lost 2 protons, that 90 is going to become an 88. We'll look up what exactly that element is in a minute. Now I'm going to go, let's do a beta decay. Let's do beta minus. When I do beta minus decay, that is when I turn a neutron into a proton. So since I'm turning one particle into another, I'm not actually going to change my mass at all. It's still there. It's just a different particle. So that is going to still be a mass of 230. I just have to remember that since I'm turning a neutron into a proton, my atomic number goes up by 1. So this is going to be 89. I'm going to figure out what element that is later. Let's do this again. Let's take this element and undergo another alpha decay. When I do alpha decay, remember I subtract away 4 from my mass. So this is going to become 226. And then since it's alpha decay, I lose 2 protons, which means 89 minus 2. My atomic number is now going to be 87. We'll look up what element that is later. Let's do another beta minus decay. Notice that every time I'm doing beta minus, I'm going up and to the side, and every time I'm doing alpha decay, I'm going down. Just keeping up with tradition, and also it makes it easier to read. Okay, so we're doing another beta decay. So that means my particles change, but they're still the same number. So that means my 226 is still going to be 226. And then my atomic number, my number of protons, changes because I turned a neutron into a proton. So that 87 now becomes an 88. All right, let's figure out what elements these are. If I go to my periodic table, I can see that element 88 is radium. Element 89 is actinium. And then element 87 is francium. And then we have element 88 twice, so that's going to be radium again. And I'm getting that. Oh, this is going to let me write. Yes. Radium, actinium, francium, and then back to radium. So let's fill it in. Element 88, that was radium. Element 89, that was actinium. Element 87, that was francium. And then element 88 is radium again. Hopefully this helps you guys create your own. Something that you might be wondering is like, well, what about those neutrinos and positrons? Those have such little mass that we do not account for their masses in our atomic mass. So even though they're gone, they're somewhere else, they've been emitted, we do not count them when we are calculating atomic mass. So we do not have to account for them when we make our decay schemes in this class. If you have any questions, let me know. Have a good day.